All right, so just a reminder from back in like Chem 102, remember that all of our reactions don't really reach an endpoint, they just reach an equilibrium, right? So they're always transforming into other things, but it's just that it's at an equilibrium, and so overall it looks like nothing's happening, right? So the vast majority of reactions that we talk to, it's not A transforming into B, it's A in equilibrium with B, right? They're going back and forth. So for example, if we have some kind of nucleophile adding onto here, right? Obviously, to add the nucleophile would attack. And then to go back to the original structure, right, we would kick this pi bond back down and then kick off the nucleophile. And so which side of the equilibrium is favored depends on, the mechanism of the reaction and how likely these things are to occur. So for example, if your nucleophile is something like an alkyl chain, take for example an Grignard reaction, an alkyl chain is not just going to simply leave, right? Because then we're left with some kind of C-, which is generally not favored. And so in that case, the products really are favored over the reactants, right? We're gonna form more so the alcohol or the precursor to the alcohol. If, for example, your nucleophile is like a chlorine, so for example, if you add some HCl in the presence of a ketone, they will react. However, since the chlorine is such a good leaving group, it's the reactants are going to be favored, right? That chlorine is going to attach, but then it's just going to go ahead and leave, and the vast majority of your compounds will stay to the left. This is important to note because we'll see some intermediates and whatnot that could be important, even though it's not quite obvious that they are part of the mechanism.